Welcome back, guys. Today we'll be doing January 2021 question number 10E. Let's get started. For this question, we're given the matrix W, which is a 2 by 2 matrix. We need to determine the 2 by 2 matrix L such that W plus L is equal to 0, 0, 0. Now, what we're going to do, we're going to create a matrix L with unknowns. So let L be equal to the unknown that we need to find. So I am going to develop a 2 by 2 matrix. So here we have the 2 by 2 matrix with the unknown that I need to find, A, B, C, and D. And how did I know it's a 2 by 2? Because it was given in the question. Now I'm going to substitute it into the question itself where it says W plus L is equal to 0, 0, 0. And I'll be replacing what is W and what is L. So W, I replace it with the matrix that is given in the question, 3, 6, minus 2, and 5. And L with the unknown, that's what I'm trying to find. What is A, what is B, what is C, and also what is D. Whatever the values, when I add matrix W plus matrix L, I will get 0, 0, 0. That is what this equation is saying. So using this concept, I must get 0, 0, 0, 0. When you're adding two matrix, we add the positions. So we add 3 plus A, and whatever is A, it should give us 0. Also, we can go ahead and solve this by carrying over the 3 over the equal sign. So A is equal to negative 3. Now it's the same concept. When I add 6 plus B, I should get 0. So we add the same positions and it should give us 0. So here I have an equation I can go ahead and solve. So carry the 6 over the equal sign. So B is equal to negative 6. Next, I will look at the next position. Minus 2 plus C should give me 0. So writing this as an equation, I will have minus 2 plus C is equal to 0. And solving, we carry the minus 2 over the equal sign. So C is equal to positive 2. Finally, we can go ahead and add 5 plus D. It must give us 0. And having this equation, I can solve. So solving, carry the 5 over the equal sign. So it becomes negative 5. So D is equal to negative 5. So here we have the values. And that is the values that we're going to substitute to create matrix L. So A is negative 3, so I replace that position with negative 3. And B is negative 6, I replace that position with negative 6. And C is 2, so I replace that position with 2. And D is negative 5, and I replace that position with negative 5. And this is our matrix L. That's it. However, we have another way that we can work this out. So the alternative method is as follows. We have the same equation, just instead of writing A, B, and C, and D, for L, I just have L. So it's like making X a subject. We know we'll have to carry this matrix over the equal sign, so there's a sign change, just like making X a subject. For example, if I have 2 plus X is equal to 4, then I will carry this is positive. We're not seeing any sign, but we know it's positive, so it will be negative. So I will have form take away 2. So it's the same concept that I'm applying here. Because there's no sign in front of the matrix bracket, I say it's positive, so it's good. When I carry it over the equal sign, it becomes negative. So we have the first matrix 0, 0, 0 minus the second matrix 3, 6 minus 2 and 5. So then we're going to subtract the positions and we will have the matrix L. So doing this, I will have 0 minus 3, that's negative 3. Then 0 minus 6, that's negative 6. 0 minus and minus, that's plus, so that's positive 2. And 0 minus 5, that's minus 5. And that's it. For the next question, we have a 2 by 2 matrix P that we need to find, where WP is equal to 1, 0, 0, 1. Now, W was given in the first part of the question, where we have W to be 3, negative 2, 6, and 5. P is what we're trying to find, but we have it being equal to 1, 0, 0, 0, 1. Now, when we have 1, 0, 0, 1, it's actually the identity matrix. That when we multiply the matrix W by its inverse, it gives us this. So P is actually the inverse of W, because only the matrix times its inverse gives you the identity. That's always the case. Matrix times W gives you identity. Now the identity for a 2 by 2 matrix is 1, 0, 0, 1. And that means that this should be a 2 by 2 matrix. We can find the inverse of W to get the identity when we multiply it by W. So to find the inverse of W, it's 1 over the determinant times the adjoint. So first, I have to find the determinant. The determinant of W is equal to, I multiply 3 times 5, so 3 times 5, minus 6 times negative 2. So 3 fives, 15, minus negative 2 times 6, that's negative 12. Negative and negative, that's positive. So I have 15 plus 12, that will give me 27. So the determinant of W is 27. So now to find the inverse of W, which will represent P, is 1 over the determinant, which is 1 over 27, and the adjoint is being multiplied. So we have 3 and 5 being switched in position, so that's 5 and 3, and then 6 being changed to negative 6, and minus 2 being changed to positive 2. Now this right here is matrix P, the 2 by 2 matrix, but we can rewrite it in a different form, where we multiply each of these by 1 over 27. Now, please note, you're multiplying a fraction times a whole number. We put the whole number over 1 and say 1 times 5 is 5, all over 27 times 1, that's 27. So in other words, when I multiply the fraction by the numbers, 5 times 1 over 27, that's 5 over 27. 1 over 27 times negative 6 will give us minus 6 over 27. 1 over 27 times 2, that's 2 over 27. And 3 times 1 over 27, that's 3 over 27. Now I can go further by reducing 2 of the fraction. So 5 over 27 is okay as it is, but 3 can go into 6 2 times, and 3 can go into 27 9 times. So this is minus 2 over 9. The next one, we have 2 over 27, that's okay as it is, and we have 3 over 27. 3 can go into 3 1 time, and 3 into 27 9 times. So this is 1 over 9. So this represents the matrix P, and this is the answer for this question. And that's it. Thanks for watching, guys. Don't forget to like and subscribe to my channel. Have a great day.